Hello everyone, and welcome to our session on AWS, Amazon Web Services. Today, we are kicking off with Lecture 2. I'm excited to have you all here. In this presentation, we'll explore the fundamentals of AWS and its key services. We'll cover what it is, how it works, and why it's so important in today's cloud computing landscape. So let's get started and dive into the world of AWS together. Cloud computing is essentially the delivery of a wide range of computing services, including servers, storage, databases, networking, software, analytics, and intelligence all over the internet, which we often refer to as the cloud. The idea here is that you pay only for what you use, similar to how electricity works. You don't buy a whole generator, you just pay for the power you consume. This allows you to access your data and applications from anywhere, as long as you have an internet connection. For example, popular services like Netflix, Gmail, or Google Drive all rely on cloud computing to deliver their services seamlessly. The term cloud was chosen because it's a metaphor inspired by how clouds in the sky form through the accumulation of gases and moisture, eventually leading to rainfall. In a similar way, cloud computing gathers various resources and services, making them available on demand. One of the key benefits of cloud computing is that there are no upfront costs or maintenance worries. You can simply access what you need instantly and flexibly. It offers on-demand resources, meaning you can scale up or down as needed, providing both scalability and flexibility. It's also highly cost-effective, reliable, and secure. When we look at the major players in this field, companies like AWS, Microsoft Azure, Google Cloud Platform, IBM, Alibaba, and Fujitsu stand out as leaders. Before moving on, let's quickly recap what we covered earlier. Cloud computing is transforming how we access and manage technology, making it more accessible, flexible, and cost-efficient. Let's take a closer look at the certification path. AWS launched its global certification program back in 2013, marking a significant step in validating cloud expertise worldwide. Over the years, this certification path has grown and become more structured, helping professionals demonstrate their skills effectively. The certifications are divided into different categories, each designed to target specific roles and expertise levels. These categories ensure that whether you're just starting out or are an experienced professional, there's a clear pathway for you to develop and showcase your AWS knowledge. Understanding these categories is crucial because they align with different career goals and technical focuses, from foundational skills to advanced cloud architecture. By following this structured path, you can systematically build your cloud expertise and increase your value in the job market, all while aligning with the overall goal of mastering AWS technologies. All right, let's talk about the foundational and associate level certifications, starting with the AWS Certified Cloud Practitioner, which is designed for those who are just beginning their cloud journey. It's a foundational level exam, meaning it covers the basic concepts of AWS and cloud computing in general. The exam itself consists of multiple choice questions, so it tests your understanding through straightforward questions. You'll have 90 minutes to complete it, so it's important to manage your time effectively. The cost for this exam is $100, and if you want to try a practice exam beforehand, that's an additional $20. Moving on to the associate level, the most common certification is the AWS Certified Solutions Architect. This is a step up in complexity and scope, focusing more on designing distributed systems on AWS. It's an associate level exam, still multiple choice, but it requires a deeper understanding of architecture principles. The exam duration is 130 minutes, giving you a bit more time to analyze complex scenarios. The cost is $150, with a practice exam available for $20. These certifications are key stepping stones in building your AWS expertise. They set a solid foundation for more advanced certifications and help you demonstrate your cloud skills professionally. Whether you're just starting out or looking to deepen your knowledge, these exams are designed to test your understanding and readiness to work with AWS in real-world situations. Let's take a closer look at the AWS Certified Developer level, Associate. This certification is designed for developers who want to demonstrate their ability to build and maintain applications on AWS. The exam primarily consists of multiple choice questions, which test your knowledge across various AWS services and best practices. You'll have 130 minutes to complete the exam, so time management is key. The cost for the exam is $150, and if you want to practice beforehand, there's a practice exam available for an additional $20. Moving on to the AWS Certified SysOps Administrator, also at the associate level, this certification is more focused on deploying, managing, and operating applications on AWS. Like the developer exam, it's made up of multiple choice questions, and the duration is the same, 130 minutes. The cost is also identical at $150, with a practice exam option for $20. Both of these certifications are integral to the overall AWS certification pathway, helping you showcase your technical skills in different areas, whether it's development or operations. They're designed to validate your ability to work effectively within the AWS environment, aligning perfectly with the broader goal of enhancing your cloud expertise and career growth. Now, let's take a look at the professional level certifications. First up, we have the AWS Certified Solutions Architect at the professional level. This exam builds on the associate level, so it's recommended that you have already completed the AWS Certified Solutions Architect Associate exam. The format of this exam is multiple choice questions, and you'll have 180 minutes to complete it. The cost is $300, but there's also a practice exam available for $40 if you want to prepare more thoroughly. Moving on, we have the AWS Certified DevOps Engineer, also at the professional level. This certification is designed for those who have already earned the AWS Certified Developer and SysOps Administrator Associate certifications. It's also a multiple choice exam, with the same 180-minute duration and cost of $300, plus the option for a practice exam at $40. These certifications are crucial for demonstrating advanced skills in designing, deploying, and managing complex AWS solutions. They highlight your ability to handle real-world challenges and optimize cloud environments effectively. So, whether you're aiming to deepen your expertise as a solutions architect or to showcase your DevOps capabilities, these professional certifications are valuable milestones in your AWS journey. In cloud computing, services refer to the different types of computing resources and solutions provided over the internet by cloud providers. These services are categorized into three main models, each offering varying levels of control, flexibility, and management. Now, you might be wondering, what's the role of runtime and middleware in this context? Well, runtime includes the environment where your applications run, like the operating system or platform-specific components, while middleware acts as the bridge that connects different software applications and services, enabling them to communicate and work together smoothly. Together, runtime and middleware help ensure that applications are flexible, scalable, and easier to manage across various cloud service models. So, understanding their roles is key to choosing the right cloud solution for your needs. And remember, if you have thoughts or questions about runtime and middleware, feel free to share them in comments or on Instagram. Now, let's take a closer look at what Infrastructure as a Service, or IaaS, actually provides. Essentially, it offers virtualized computing resources like servers, storage, and networking over the internet. Think of it as renting the IT infrastructure you need without having to own or maintain the physical hardware. When it comes to responsibilities, the user, meaning you or your organization, manage the operating systems, middleware, applications, and data. You're in charge of everything that runs on that virtualized infrastructure. On the other hand, the cloud provider handles the underlying hardware, virtualization processes, storage solutions, and network management. They ensure that the infrastructure is reliable and scalable, so you can focus on deploying your applications and data. Now, IaaS is incredibly versatile and has a wide range of use cases. For example, it's commonly used for hosting websites, because it provides scalable and flexible resources. It's also vital for disaster recovery plans, allowing organizations to quickly recover data and systems in case of failures. And for big data analysis, AWS provides the computational power needed to process vast datasets efficiently. Some popular examples of AWS providers include AWS EC2, Microsoft Azure Virtual Machines, and Google Compute Engine. These platforms give you the flexibility to build, deploy, and manage your infrastructure in the cloud, aligning perfectly with the overall theme of cloud computing's agility and scalability. So what does PaaS actually provide? Essentially, it offers a platform that allows developers to build, deploy, and manage applications without having to worry about the underlying infrastructure. This means you can focus on your code and functionality, while the platform takes care of the rest. Now, when it comes to user responsibilities, developers are mainly tasked with developing and managing their applications. They don't need to handle the servers, operating systems, or middleware. That's all managed for them. On the other hand, the provider's responsibilities include maintaining the operating system, runtime environments, middleware, servers, storage, and networking. This division of responsibilities helps streamline development processes and accelerates deployment. PaaS is particularly useful for various use cases like app development, database management, and DevOps tools. It provides the flexibility and tools needed to create, test, and scale applications efficiently. Some well-known examples of PaaS platforms include AWS Elastic Beanstalk, Google App Engine, and Microsoft Azure App Services. These platforms exemplify how PaaS simplifies application deployment and management, making it easier for developers to innovate without being bogged down by infrastructure concerns. So, what does software as a service, or SaaS, really provide? Well, it offers ready-to-use software applications that are hosted in the cloud and accessed easily through a web browser. This means users don't need to worry about installing or maintaining the software themselves. It's all taken care of in the cloud. In terms of responsibilities, the user mainly manages their data and who can access it. Everything else, like the underlying infrastructure, the operating system, the software itself, and even updates, is handled by the service provider. This setup really simplifies IT management for organizations. SaaS is commonly used for a variety of applications like email platforms, customer relationship management tools, and collaboration software. Think of Gmail for email, Salesforce for CRM, Microsoft 365 for productivity, or Zoom for virtual meetings. These examples highlight how SaaS can support different business needs seamlessly. Ultimately, SaaS is a powerful model because it provides scalable, accessible, and cost-effective solutions that align with our overall goal of leveraging cloud technology to make work more flexible and efficient. Now, let's take a closer look at some of the key cloud service models. First, we have Function as a Service, or FaaS, also known as serverless computing. This allows you to run your code in response to specific events without the need to manage any servers. For example, AWS Lambda lets you execute code only when it's needed, making it highly scalable and cost-efficient. Next, there's Database as a Service, or DBaaS. This provides managed cloud databases like Amazon RDS or Google Cloud SQL. Essentially, it means you don't have to worry about the underlying infrastructure or maintenance. It's all handled by the provider, so you can focus on using the data. Then we have Container as a Service, or CaaS. This service manages containerized applications with platforms like AWS ECS or Google Kubernetes Engine. It simplifies deploying, managing, and scaling containerized apps, which is especially useful for modern, microservices-based architectures. It's important to note that there are even more cloud service models out there. For instance, Backend as a Service or BOS, and other as a service options like Communication as a Service or XaaS. These models expand the possibilities of cloud computing, offering flexible solutions tailored to different needs. Now, let's talk about why these service models are so vital. The key benefits include scalability. You can easily adjust resources up or down as your needs change. Cost efficiency is another big advantage, thanks to pay-as-you-go pricing with no upfront hardware costs. Accessibility means you can access these services from anywhere with an internet connection. And finally, maintenance is largely handled by the providers, so you don't have to worry about updates or security patches. All of these models form the foundation of cloud computing. They enable businesses and individuals to harness powerful computing resources without the complexity of managing physical infrastructure. This is what makes cloud solutions so transformative and versatile in today's digital landscape. Next, we'll be diving into the deployment model of cloud computing. This is a crucial aspect because it determines how the cloud services are actually delivered and managed. When we talk about deployment models, we're referring to the different ways organizations can set up their cloud environments. There are primarily 4 models to consider: public, private, hybrid, and community clouds. Each of these has its own advantages and best use scenarios. For example, public clouds are great for scalability and cost efficiency, as they're accessible to anyone and hosted by third-party providers. Private clouds, on the other hand, offer greater control and security, making them ideal for sensitive data and enterprise needs. Hybrid clouds combine elements of both, allowing organizations to enjoy the flexibility of public clouds while maintaining critical operations on private clouds. And community clouds are shared among organizations with similar interests or requirements, often for specific collaborations. Understanding these deployment models is essential because it helps organizations align their cloud strategy with their security, compliance, and operational needs. As we wrap up this presentation, keep in mind that choosing the right deployment model is a key step toward maximizing the benefits of cloud computing while managing potential risks.